Hi everybody, you're back at Retired Grandpa's Electronics 101. Last week we have talked about resistor and their color coding, and this time we'll take up resistors, inductors, and capacitors in series in parallel connection. Okay, let's start with that. Let's start with the resistor. So we have a series connected resistor. It looks like this. So, or can be more than two. Let's just simplify it, just two. So we have R1 and R2. Now, the total resistance of that is equal to R1 plus R2. Okay. Say, let's get some example. You have a 10 ohm resistor and you have a 50 ohm resistor. So the total resistance of that would be 10 ohm plus 50 ohm, or equivalent to 60 ohm. Okay. Now let's say you connect that in a parallel mode. Parallel connection. It would look like this. Oh. Look like this. Say we have R1 again and R2. So say we also have the same ohm resistor 10 ohm and then 50 ohm. So the formula for the total resistor of parallel connected resistor is the product of the two divided by the sum of the two. Okay. So it's 10 times 50 over 10 plus 50, equivalent to 500 over 60. So the total resistance ends up to be 8.33 ohm. So one thing you would notice is the resultant resistance is always smaller than any of these original resistors. Okay. Okay, that's for the resistor. Let's go to inductor. An inductor. The inductor in series. So it will be something like this. Let's put together. So inductor, we term it as L. So L1, L2. Okay. The total inductance would be L1 plus L2, same as this is resistor. So again, we have another of two lines. Inductance is normally very small, so let's say, and the term is Henry, 3 Henrys, and 5 Henrys. So H stands for Henry. Okay, so the total inductance is equal to L1 plus L2, or 3 plus 5, equal 8 Henrys. Okay. How about in a parallel connection? So it is like this. So we call it L1 and L2 again. So the inductance tolerance, the inductance total is same as resistor, the product over the sum. Okay. Say you have 3 and 5, okay, again, 3 Henrys and 5 Henrys. So it would come up to be 3 times 5, 3 plus 5 equal 15 over 8. So the total inductance would be 1.875 Henrys. Again, same as resistor, if 2 Henrys or 2 inductances are in parallel, the result will be smaller than the smaller value, which is great. Okay. Now let's go to the capacitor. The capacitor is in first we take up series one. So it looks like this. It has the symbol of the capacitor, C1, C2. Okay. The total capacitance of a series capacitor is the invert of a resistor. So product over the sum. Okay, C1 times C2 or C1 plus C2. Say you have a 10 microfarad. That is the term, the symbol for microfarad. And let's say we have a 50 microfarad. So let's calculate the total capacitance is equal to 10 times 50 over 10 plus 50 is equal to 500 over 60. Cancel the two zeros. 50 over 60. So total capacitance is 8.33 microfarad. Okay, so again in opposite the resistor, the resulting total will be smaller than the smallest connected capacitor. Okay. Now let's try a parallel connected capacitor. So it's similar to that. Let's call it C1 and C2 again. So the total capacitance is invert of the resistor. So it is equal to C1 plus C2. Say, example, we have a 10 microfarad and a 50 microfarad capacitor. Your C total is equal to 10 plus 50 is equal to 60 microfarad. Okay, it's just like a resistor. Okay. Now we've taken up the series and parallel connection of a resistor, of an inductor, and a capacitor. Okay, the next topic will be an actual building of a circuit. I think we will start with a regulated 5 volt or 5 or 6 volt power supply. Okay, so before we can go to the next projects, we must have a power supply to start with.